Welcome back to the Techmoto channel and the next video in the Iron Man robot series. So head and neck are finished. Next thing to do is start working on another part of the body. I quite fancy working on the forearm and hands. So that's what we're going to do next. And the first thing to do is to get some 3D printing done. Okay, so loads of people ask me how I print such large parts when my 3D printer is an Ultimaker 3 and the bed is only of a certain size and the height is only a certain size. So here's a part that I've got to print next. This is the forearm. So this is the bit the hand is going to match onto down here. It's way too big, so next to it is the envelope of my Ultimaker 3. So what we're going to do over here, this is a piece of software called Mesh Mixer. We're going to go to Plane Cut. And what it does is it gives you a cut on your part. Now you can move this cut up and down so you can have it wherever you want it. So if you go about halfway and then over here you say cut and keep both, accept, and then you go to separate shells. Now that'll think for a little while, and then it will cut these two parts in half, so you end up with two parts. So just here you have part one, part two, part one, part two, and then you can export these individually, and then you can import them into Cura to print as individual parts. Then you've just got to stick them together. So you can either use super glue, or one of my family said that you can almost sort of TIG weld, if you like, with a soldering iron and some of the filament. I've not tried that yet, but I might try that with this. So cut it in half, put it into the Ultimaker in two parts, stick it together. You might have to use some car body filler or something just to smooth it over, make it look like one part again, but that's how you print two parts. So we have our various parts. We've got our fingers. They're all separated, but they're just held together with gaffer tape at the moment. We've got a hand with the LEDs on the inside. Got a little lens to go over that, which I'm going to frost on the laser cutter, so it looks like sort of electronic circuits. We've got a thumb, which again is held together with gaffer tape. A bit of wire coming out of there, which lights up the LEDs. We have our forearm, which is made in two parts. You can just see the join around the outside of there, which is now all stuck together. We have the top of our hand, which is still in the process of trying to get that flat and looking nice with putty primer paint and throwing some red paint on there just to see what it looks like. And then we've got another part here which I'm not quite sure what this does, but I think this connects everything together. Anyway, next step is to have a look at how we make the hand robotic. Now, there's various options for doing this. A lot of people put cables down the inside of the finger, so when you pull on the cable, it pulls the finger tight, and then you spring load it, so when you release it, it springs back out. You can use pneumatics, hydraulics, you can do all sorts of stuff. I think I want as much functionality as possible, and I want to be able to program it. So I think I'm going to put a servo in each joint of each finger and each joint of the thumb. Now, that makes for a lot of servos. So I've got this box full of bits here, lots and lots and lots of tiny servos, because they don't need to lift a huge amount of weight. They need to be as small as possible, and I need a lot of them. So I've got a few. I don't think I've quite got enough, but we're going to see if we can put them together in the fingers. So let's have a go at that. Okay, so I've made it into a little finger, and all the joints work in the way that you would want them to work, but it's a little bit flimsy. This acrylic is thin. It's not held onto the servos with very much. I could put a hinge on the back to match the front, so that would give it a bit more support, but with just the shape of it isn't quite right. It's a bit chunky. It's not very strong. So I think I'm going to reproduce it, and I'm going to 3D print it. Okay, so those 3D prints are done. Problem is that although it works, and this fits together quite nicely in here, and then these fit over the top of this one, and you get quite a nice mechanism, the problem is they're just too big. So if you take the fingers, for example, and put them next to it, this is the little finger, and you can see that to get 3 of these inside a little finger is going to be impossible. Now I could enlarge the hand, but I want to keep it authentic as best I can. I mean, the hand looks quite cool as is. So I think what I'm going to do is I'm going to 3D print some more parts, and I'm going to sack off the idea of using servos in the hand. Put the servos in the wrist, and then use cables to pull the fingers. So when the servo turns one way, it pulls on one string and it releases the other string, and when it turns the other way, it does vice versa. And so it will release and pull the fingers. It's a little bit more complicated. It's quite an intricate design on SolidWorks, but we'll give it a go. Okay, so bit of a discovery. I decided that instead of designing my own fingers, which would take forever, I'd just have a look on Thingiverse. And there's a variety of different robotic hands on there, some good, some bad, some okay. But there was a good one on there that had some really nice finger joints. So I've stolen the files for the fingers, and I've just pulled them off the board, drilled a few more holes in them and put them together. So these fingertips go on the end of each one of these. But the idea is you put a string, like a tennis racket string, through the end. One goes over the top, and then you tie a knot when it comes through this hole at the top, and the other one goes along the bottom, and then you tie a knot when it gets to the end. So the idea being, let me just clip this to the table so I can show you. The idea is that the string across the top, when you pull that, it pulls the finger straight. When you pull the string at the bottom, it curls the finger up. Pull the top one, pulls it back out. And then when you've got your knots in the end here, you just glue on the fingertip over the top of the knots, and you wouldn't even really know that there's any cables in there. And then you attach all of these to a hand and do the same thing with that, so that when you pull the string, it pulls the whole finger round like so. And hopefully then you'll have 4 fingers and a thumb. And then I should be able to take the existing Iron Man print, and let's find the small finger. So that's that one, that's that one, that's that one. And the small finger, and put the small finger inside here, like this, so the joints line up like that. So that should, if I get some smaller bolts in there, be able to go in there like that. And so when you bend the finger joint, it actually bends the armour as well. So that's the plan. Whether it'll work or not, I don't know. But we've got a few more 3D prints going over here. So we have part of the arm where all the servos are going to have to go in, because of course the servos are going to have to pull the strings now. They won't be operating the fingers directly. And then this one here is the thumb printing off. So as soon as those are printed, I'll print a main part of the palm to go inside the palm of the Iron Man armour. And then we can see if we can get it up and running.